Hello students, welcome to the lecture on Introduction to Programming in C. And after the lecture we will be able to learn the following objectives. Understand the C language preliminaries. Describe the statements and symbolic constants. Define the data types and identifiers. Explain the problem-solving methods in C. Discuss how to trace flowcharts. Explain the need for computer languages. Let's start with a brief introduction to programming in C. C is a practical and still current software tool. It remains one of the most popular programming languages in existence, particularly in areas such as embedded systems. C facilitates writing code that is very efficient and powerful, and given the ubiquity of C compilers, can be easily ported to many different platforms. Also, there is an enormous codebase of C programs developed over the last 30 years, and many systems that will need to be maintained and extended for many years to come.
Why should I learn C programming language?
It is one of the widest used of all programming languages, including its variants. And it has been around for a long time.
That's like saying I should learn Latin. It was used for centuries across Europe, and in theory learning it makes Italian and Portuguese easier.
Learning C teaches you many good practices that help you as a programmer, though it can be time-consuming to learn.
C is often called a low-level language. You can jump in and get started with other languages, high-level languages like Java or JavaScript.
Learning something like C teaches you more about data types, pointers, passing values by reference. In the end, this makes you a better programmer.
That's as bad as someone saying I should learn Haskell to learn programming discipline. Yoga would be better.
If you want to get into programming, learning C is going to give you a phenomenal head start.
Because it has been around for 30 years and I can find a job migrating their systems?
Because it is hard, so once you learn that, everything else is easier.
If it is that hard, I want to learn an easier language like Objective-C or Java.
Learn C, and C++ and C# and Objective-C are all minor variations you pick up quickly instead of 3 new languages to tackle.
C is a functional programming language. Most modern applications are object-oriented.
Object-oriented code is easier to use and reuse. C is far faster to execute on the server.
So my efficiency is irrelevant.
They only pay you once to write or edit the code. On the plus side, you don't have as many code modules to debug if something goes wrong in C.
This feels like I'm asked to master the difficult task of changing the car battery and replacing tires before I'm allowed to drive.
You should understand what goes on under the hood before you start driving. Then you'll realize when things go wrong before the damage is too great and you wreck.
I figured the red check engine warning lights were good enough.
The warning is as indecipherable as most software error messages.
Let's discuss the C language preliminaries. C is a general-purpose high-level language that was originally developed by Dennis Ritchie for the UNIX operating system. It was first implemented on the Digital Equipment Corporation PDP-11 computer in 1972. The Unix operating system and virtually all Unix applications are written in the C language. C has now become a widely used professional language for various reasons. Easy to learn, structured language. It produces efficient programs. It can handle low-level activities. It can be compiled on a variety of computers. Facts about C. C was invented to write an operating system called Unix. C is a successor of B language, which was introduced around 1970. The language was formalized in 1988 by the American National Standard Institute, ANSI. By 1973, Unix OS was almost totally written in C. Today, C is the most widely used system programming language. Most of the state-of-the-art software has been implemented using C. Use of C. C was initially used for system development work, in particular the programs that make up the operating system. C was adopted as a system development language because it produces code that runs nearly as fast as code written in assembly language. Some examples of the use of C are operating systems, language compilers, assemblers, text editors, print spoolers. Network drivers, modern programs, databases, language interpreters, utilities. Let's now talk about the C character set. Character denotes any alphabet, digital, or special symbol used to represent information. The character set is the fundamental raw material of any language, and they are used to represent information. The characters in C are grouped into two categories: source character set, alphabets, digits, special characters, white spaces, execution character set. Let's talk about each of them. Source character set. Alphabets are uppercase letters A to Z, lowercase letters A to Z. Digits. C language comprises the sequence of numbers to associate the letters 0 to 9 digits. Special characters. C language contains the special character in association with the letters and digits. White spaces. It is any character or series of characters that represent horizontal or vertical space in typography. Execution character set. Certain ASCII characters are unprintable, which means they are not displayed on the screen or printer. Those characters perform other functions aside from displaying text. Examples are backspacing, moving to a new line, or ringing a bell. They are used in output statements. Escape sequence usually consists of a backslash and a letter or a combination of digits. An escape sequence is considered as a single character but a valid character constant. Let's now talk about identifiers. The identifier may be the name of variable or constant or function. Usually for all programming languages, the first character of an identifier will be an alphabet, followed either by numbers or alphabet up to a maximum length, which depends upon the compiler limitations. All C compilers are case sensitive. Underscores are allowed for better readability, and no special characters are allowed while defining an identifier. Look at the example to understand better.
Identifiers in C are tokens used to give recognizable names to variables, functions, labels, and defined types. In C and C++, identifiers consist of the ASCII representation of the 26 letters of the ISO basic Latin alphabet, both in lowercase and uppercase, the 10 Western Arabic numerals, and the ASCII underscore character. Identifiers may not begin with a number. Identifiers may not conflict with reserved words. The current C language standard, C11, reserves 43 words, and the current C++ standard, C++11, reserves 73 words. You cannot use any of these words as an identifier. Identifiers are case sensitive, so this AZ on the left is different from the AZ on the right. So even though these both say AZ, they are different identifiers. Current standards allow letters that are not part of the ISO basic Latin alphabet, but support for this is implementation dependent and it is not portable. I highly recommend that you stick to the 26 letters of the basic Latin alphabet, numbers, and the underscore. Using international character sets is not portable. Current standards allow identifiers to be of any length, although only the first 63 characters are guaranteed to be checked for uniqueness, and only the first 31 characters are guaranteed for external identifiers. So in practice, you should keep your identifiers under 31 characters long. An initial underscore character, that is, an underscore in the first position of an identifier, is commonly used for private identifiers. More than one initial underscore is normally reserved for system-level private use, so don't name your variables with two initial underscores. Like so many aspects of programming, it's a really good idea to decide on a consistent style for choosing your identifiers and stick to that style. Understanding the rules, choosing conventions, and sticking with them will help to make your code more readable and maintainable for the long term.
Let's now talk about keywords. Keywords are words that have special meaning to the C compiler. These reserved words may not be used as constant or variable or any other identifier names. While naming the functions and variables other than these names, one can choose any names of reasonable length for variables, functions. An example is shown here. We shall now talk about data types. C has a concept of data types, which are used to define a variable before its use. The definition of a variable will assign storage for the variable and define the type of data that will be held in the location. The value of a variable can be changed at any time. C has some basic built-in data types: int, float, double, char. There is not a Boolean data type. Int data type. Int is used to define integer numbers. Float data type. Float is used to define floating point numbers. Double data type. Double is used to define big floating point numbers. It reserves twice the storage for the number. On PCs, this is likely to be 8 bits. Char data type. Char defines characters. Qualifiers. A type qualifier is used to refine the declaration of a variable, a function, and parameters by specifying whether the value of a variable can be changed. The value of a variable must always be read from memory rather than from a register. Standard C language recognizes the following two qualifiers: constant, volatile. Const. The const qualifier is used to tell C that the variable value cannot change after initialization. Constant float pi equals 3.14159. Now pi cannot be changed at a later time within the program. Another way to define constants is with the hash, defined pre-processor, which has the advantage that it does not use any storage. Volatile. The volatile qualifier declares a data type that can have its value changed in ways outside the control or detection of the compiler, such as a variable updated by the system clock or by another program. What are arrays? One has seen all basic data types. In C language, it is possible to make arrays whose elements are basic types. Thus, one can make an array of 10 integers with the declaration int times 10. Array initialization. As with other declarations, array declarations can include an optional initialization. Scalar variables are initialized with a single value. Arrays are initialized with a list of values. The list is enclosed in curly braces. An example is shown here. Let's discuss the concept of declarations. All variables must be declared before they are used. They must be declared at the top of a block before any statements. They could be combined into a single statement as float inches, centimeters. The compiler, on parsing the declaration statements, put aside memory space for each of the variables declared. Let's discuss the concept of statements and symbolic constants. The statements of a C program control the flow of program execution. In C, as in other programming languages, several kinds of statements are available to perform loops, to select other statements to be executed, and to transfer control. Constants. The difference between variables and constants is that variables can change their value at any time, but constants can never change their value. There are a few types of constants. Numeric constants. One has various data types like integer, floating point number, and character in C. Constants of numeric types may appear in programs. In the statement here, 2 is a constant. Character constants. Character constants are single character enclosed in single quotes like A, G, 5, question mark, and plus sign. String constants. In the statement, enter a length in inches is a string constant. In the memory, a string contains an invisible character, /0, at the end. This invisible character is known as the null character. Therefore, a string ABC actually contains 4 characters instead of 3. Now we shall understand what the concept of problem solving. There are different ways of representing the logical steps for finding a solution of a given problem. They are algorithm. Algorithm is a very popular technique used to obtain a solution for a given problem. The algorithm is defined as the finite set of steps, which provide a chain of actions for solving a definite nature of problem. Each step in the algorithm should be well defined. For example, to establish a telephonic communication between 2 subscribers, the steps to be followed are: dial a phone number, phone rings at the called party, caller waits for the response, called party picks up the phone, conversation begins between them. After the conversation, both disconnect the call. Another real-life example is to access internet through internet service provider with dial-up facility. To log on to the internet, the steps to be followed are: choose the internet service provider for accessing the internet. Obtain from service provider a dial-up number. Acquire IP address of the service provider. Acquire login ID and password. Run the internet browsing software. Flowchart. A flowchart is a graphic representation of how a process works, showing at a minimum the sequence of steps. A flowchart shows logic of an algorithm, emphasizes individual steps and their interconnections. Pseudocode. Pseudocode is an artificial and informal language that helps programmers develop algorithms. Pseudocode is a text-based detail algorithmic design tool. Now let us talk how to trace flowcharts. There are some basic symbols commonly used in flowcharting of assembly language programs: terminal, process, and input-output, decision, connector, and predefined process. General rules for flowcharting. All boxes of the flowchart are connected with arrows, not lines. Flowchart symbols have an entry point on the top of the symbol with no other entry points. The exit point for all flowchart symbols is on the bottom except for the decision symbol. The decision symbol has two exit points. These can be on the sides or the bottom and one side. Generally, a flowchart will flow from top to bottom. However, an upward flow can be shown as long as it does not exceed 3 symbols. Now we shall see the advantages of flowcharts. Communication. A flowchart can be used as a better way of communication of the logic of a system and steps involved in the solution to all concerned, particularly to the client of system. Effective analysis. A flowchart of a problem can be used for effective analysis of the problem. Documentation of program system. Program flowcharts are a vital part of good program documentation. Program document is used for various purposes like knowing the components in the program, complexity of the program, etc. Efficient program maintenance. Once a program is developed and becomes operational, it needs time-to-time maintenance. With help of flowchart, maintenance becomes easier. Coding of the program. Any design of solution of a problem is finally converted into computer program. Writing code referring the flowchart of the solution become easy. Now we shall learn the problem-solving methods. There are 2 approaches to problem solving: analytical, algorithmic. The analytical approach is used mainly by mathematicians and physicists. Try and solve a problem by isolating the given quantities, determining what is to be solved, applying formula. The algorithmic approach. It uses a sequence of steps to solve problems. An example is the instructions needed to bake a cake. Assemble ingredients. Mix together. Pour into a tray. Bake in an oven. Let's see the sample program written in C. A simple program is presented here as a reference. One also takes this opportunity to revise the problem-solving process in the derivation of an algorithm. These pre-coding activities are important but too often neglected. Many people cannot wait to start typing in their codes without first investing some quality time over the design. Need for computer languages. A computer language is a language made up of formal syntax and semantics that allow users to communicate instructions to computer systems. Programming languages are by far the most common examples of computer languages, so the terms computer language and programming language are often used interchangeably. A computer cannot work without human language, and in most cases, a human cannot efficiently work in computer binary, so a higher level language is necessary to allow programmers to give instructions to computer systems. Now in the end, let us summarize what we have learned in this lecture. C is a general-purpose programming language and is used for writing programs in many different domains, such as operating systems, numerical computing, graphical applications, etc. C was initially used for system development work, in particular the programs that make up the operating system. The identifier may be the name of variable or constant or function. Usually for all programming languages, the first character of an identifier will be an alphabet followed either by numbers or alphabet up to a maximum length which depends upon the compiler limitations. The difference between variables and constants is that variables can change their value at any time, but constants can never change their value. The algorithm is defined as the finite set of steps, which provide a chain of actions for solving a definite nature of problem.